Okay, half reaction. So here's our reaction. Iron plus 3 plus aluminum solid goes to iron solid and aluminum ion plus 3. Okay, we've all seen this reaction before. We don't think anything of it, but it doesn't show everything that is happening. Okay, because this is a redox reaction. So there is a transfer of electrons. So which atom slash ion is being oxidized? What's the oxidation? Which one is losing electrons? Which one's oxidation number went up? Okay, so aluminum in its natural state has an oxidation number of 0, and it went to plus 3, which means it lost 3 electrons. So the half reaction for the oxidation of aluminum is Al solid goes to Al plus 3 electrons. That's what aluminum does. Right? That's why it has a plus 3 charge. All those charges you've seen in previous chemical reactions, they just don't write the electrons. Okay? And so everybody forgets about them, but they are important. What is being reduced? There's only one choice. The iron. So iron, how many electrons did iron pick up? 3. Why is it 3? It's not just because this gave up 3. Why did iron gain 3? How do you know it gained 3 electrons? Because it went from a charge of plus 3 down to a charge of 0, or an oxidation number of 0. That's the important thing. So it picked up 3 electrons, and you got solid iron. Okay. When you're writing oxidation or redox reactions, the half charges, one, you have to include the electrons because the overall charge has to remain the same. Okay? It's not just about balancing atoms anymore. We have to balance charges as well. Okay? All right. So one more review of what oxidation is. Oxidation is the process of releasing electrons. Or they are electron donors. And reduction is capturing electrons. Electron acceptors. Okay. And you can see this is the reduction. It captures 3 electrons. The aluminum donates its 3 electrons. Okay. Now, this bit, sorry?
Is acceptors spelled with an O or an E there?
O? Does it look like an E?
No, I literally just don't know.
Oh. Sorry, that's an O. Okay. What am I trying? I forgot what I was saying. Oh, okay. Oxidation, reduction, oxidating agents, reducing agents. Okay, this is where things will get a little confusing here. Okay. An oxidizing agent causes something to be oxidized. Okay. And this is the confusing part. If you're an oxidizing agent, you cause something to be oxidized, which means you caused it to lose electrons. So that means you gain the electrons, so you are reduced. Okay? So it causes something to be oxidized and is itself reduced. A reducing agent causes something to be reduced. And is itself oxidized. Or you can say oxidizing agents gain electrons, and a reducing agent loses electrons. So let's look at labeling this reaction. So next page. So we got silver plus copper goes to silver solid plus copper 2. What are the half reactions? So silver plus 1 goes to silver solid. How does it do that? What does it need to pick up? Gains 1 electron. So that's the half reaction. Is that a reduction or an oxidation, that reaction? It's a reduction. This is a reduction. Okay. The copper solid goes to copper 2 plus. Now you have to maintain a charge on both sides. This has a charge of 0 on this side. So how many electrons do I have to put on the right-hand side? You have to put 2 electrons. So copper lost 2 electrons, therefore it is this oxidation or reduction? So this is oxidation. Okay. So what is the reducing agent? What is the thing that caused something to be reduced? It's the copper. Copper is the reducing agent. Because copper gave up 2 electrons, those 2 electrons allow the silver to be reduced. So although copper was oxidized, it is the reducing agent. It causes the reduction. And the oxidizing agent is silver, plus 1. Is the silver plus 1. The reducing agent is the copper solid. Okay? So the thing that is oxidized is the reducing agent because it gives up electrons. The thing that is reduced is the oxidizing agent because it accepts those electrons. Again, we're not worried about balancing right now. All right, last one for today. MnO4 minus, does anybody know what that's called? You're going to see it a lot in this class because it gets used a lot in reduction. Yeah, it's permanganate. All right, it's a deep purple. You're going to see it a lot because it's used a lot in oxidation reduction reactions. Okay, so we got MnO4 minus. What's H2O2? Hydrogen peroxide. Goes to Mn plus O2 minus. We got to figure out the oxidation numbers here. So, what is oxidation number of oxygen? Is -2. We have 4 of them, so that's a -8. So, what is the oxidation number on the manganese, the Mn? Has to be plus 7, right? Because it has to add to -1. Okay. We'll do both. What's the oxidation number of oxygen in a peroxide? -1. So you have, I'll just say -1. It's an overall charge of -2. What's the hydrogen oxidation number in that peroxide? Overall, but there's 2 of them, so it's +1, right? Yeah. So each hydrogen has a +1. Okay. Manganese went from +7 to +1. Did it gain or lose electrons? It what? It gained electrons, right? Because it was the number went from 7 to 1. To go from 7 to 1, I have to gain 6 electrons. Does that make sense? So it gained 6 electrons. So Mn, was it oxidized or reduced if you gain electrons? Sorry? Oxidized or reduced? It gained electrons, so it was reduced. It GERD. So Mn was reduced. Okay. What happened to oxygen? It went from -1 charge to O2. What's its oxidation number in its natural state? 0. So what happened to it? Gain or lose electrons? It lost an electron, right? Because its oxidation number would be 0 here. So if you lose an electron, you are LEO'd, so you are oxidized. Okay. What's the reducing agent and the oxidizing agent? What caused the thing to be reduced? What was reduced? Mn. What caused the Mn to be reduced? O, but we're not going to say O, we're going to say the peroxide because it doesn't split up. Okay? So the hydrogen peroxide is the reducing agent. The oxidizing agent is the thing that caused the other thing to be oxidized. What caused H2O2 to be oxidized, or oxygen to be oxidized? We want to say Mn, but because this doesn't separate, it's a polyatomic, it's bound together, we say the whole molecule. So the oxidizing agent is MnO4 minus, permanganate ion. Okay? Does that make sense? It's a bit weird in that the thing that is reduced is the oxidizing agent. The thing that is oxidized is the reducing agent. Okay? You just got to think about it a little bit. You can complete the half reactions and then write out the reducing agents and oxidizing agents for the rest of it. And that's pretty much the end of class, peoples. Tomorrow we'll start to balance. That gets a little tedious, but it's important. Whoops.